Every time you tap on your phone or type on your keyboard, you're actually taking part in a legacy that's over 1,000 years old. In this explainer, we're going to peel back the layers on the hidden history of computer science, and you might be surprised to find that this story doesn't start in some garage in Silicon Valley, but way, way back, in the heart of the Islamic Golden Age.
So, let me ask you something. When I say the words computer pioneer, who's the first person that pops into your head?
I'm willing to bet it's one of these familiar faces, right? Charles Babbage, the brilliant Ada Lovelace, maybe Alan Turing. And yeah, they are absolute giants of the field, no question about it.
And look, their work was completely and totally monumental. But, and this is a big but, it wasn't the start of the story. Not even close. They were building on a foundation that had been laid down centuries before they were even born. So what if I told you that the real, fundamental ideas behind computing go back 1,000 years?
It's a pretty wild thought, isn't it?
Well, let's dig in and find out.
So our story doesn't start with a machine. It starts with an idea, a really powerful idea, the concept of a repeatable, step-by-step process to solve any problem. In other words, the very first algorithm. And this is the man we have to thank for it. Meet Muhammad ibn Musa al-Khwarizmi. He was a 9th century Persian scholar working in Baghdad's legendary House of Wisdom. You could say this is the guy who basically wrote the instruction manual for modern computing. You see, his book basically created the entire field of algebra. The word itself, algebra, comes from al-jabar, a term he used for one of his key operations. He came up with a system for solving problems not with pictures or specific examples, but with abstract rules that work every single time. And that is the core of computational thinking. But here's the real kicker. The word algorithm, every time a programmer writes one, every time we talk about one, we are literally saying his name. It's just the Latinized version of his name, al-Khwarizmi, algorithmi. How cool is that?
And his influence didn't stop there. I mean, this guy was a powerhouse. He helped spread the Hindu Arabic numerals, the ones we use every day. He formalized the whole concept of zero, which in Arabic is cipher, which, by the way, is where we get the word cipher. His work was so fundamental that it was the math textbook in European universities for hundreds of years.
All right, so we've got a system for solving problems. Now let's shift gears a bit and talk about how to decode secrets.
Right around the same time, another incredible mind in Baghdad, a guy named Al-Kindi, was inventing a brand new science, cryptanalysis, the art of breaking codes. Before him, if you wanted to read a secret message, it was basically just guesswork and luck. Al-Kindi said, no, we can do this with science.
And his revolutionary idea was beautifully simple, but so powerful. He realized that every language has a kind of statistical fingerprint. In any given text, certain letters just show up more often than others. And based on that, he created an actual algorithm for breaking codes. It's a clear, logical process. First, you count up how often each letter appears in a normal sample of the language. Then, you take the secret message and you count how often each weird symbol appears. And then, you just play matchmaker. The most common symbol probably stands for the most common letter, and boom, the message starts to unravel. Just think about it like this. If some weird symbol, let's call it X, shows up all over your secret message, and you know that E is the most common letter in English, well, there's a really good chance that X is actually E. It turns code breaking into a statistical puzzle. This is huge. Al-Kindi didn't just figure out how to read secret mail. He literally invented statistical analysis. And this idea is the direct ancestor of so much of our modern world, from data science and cryptography to your email spam filter and how AI understands human language.
Okay, so we've got the logic, the software, if you will, and we've got data analysis. But what about the hardware? Let's take a look at the very first programmable machines.
Back in 9th century Baghdad, there were these 3 brothers, the Banu Musa. They wrote an incredible text called the Book of Ingenious Devices. Inside, they described over 100 amazing mechanical contraptions, including a programmable organ powered by water. You could argue this was history's first truly programmable machine. The secret sauce to their inventions was something called feedback control. They designed these really clever float valves that could automatically keep the water in their machines at a perfectly constant level. It's a self-regulating system. And believe it or not, that is the exact same principle that runs the thermostat in your home or the cruise control in your car. Flash forward a few centuries, and an engineer named Ismail al-Jazari, who people now call the father of robotics, just took this all to another level. He created dozens of these mind-blowingly complex machines, including this one, a boat with 4 automated musicians that would play music for guests at royal parties.
And here is where it all connects. This is the truly brilliant part. To control the music, to program the rhythms the musicians played, al-Jazari used a rotating cylinder with pins on it. And that is the exact same mechanical principle as the punched cards that were used to program the first modern computers more than 700 years later. It's just incredible.
Okay, let's bring all this home. Because this isn't just some dusty old history lesson. This incredible legacy is right here, right now, in the technology we use every single day. Just look at this lineage for a second. Al-Khwarizmi gives us the very idea of an algorithm, the language of programming. Al-Kindi gives us data science. The Banu Musa brothers give us the logic of automation. And al-Jazari gives us the concept of programmable machines. It's a direct line. The 3 pillars of all modern computing, algorithms, data analysis, and automation, they weren't invented in the 20th century. They were pioneered and established over 1,000 years ago. It really makes you think, doesn't it? What other amazing, hidden histories are coded into the world all around us, just waiting to be discovered?